This is a supplementary video. It's an example of the QR decomposition. So let's compute the QR decomposition of this matrix, and this is problem 5.3.27c. So the first thing that you do is you look at the first column and you normalize it, and the length of the first column is radical 5, and so to normalize it you need to divide by radical 5, and so that amounts to multiplying on the right by this matrix. Because when you do that, you just get this matrix. The first column gets multiplied by 1 over radical 5, and the next two columns don't change. Okay, so that's step 1. Okay, now what's step 2? Step 2 is you look at these two columns and you want to add some multiple of the first column to the second column to make them orthogonal. And in order to do that, you take the dot product of the first of these two columns, which is 2 over radical 5 plus 1 over radical 5 is 3 over radical 5. And that says that you need to add minus 3 radical 5 times the first column to the second, and that amounts to multiplying on the right by this matrix. Okay, so when you do that calculation, the first column doesn't change, and the second column becomes, if you work it out, you get minus 1/5 1 minus 2/5, and the third column doesn't change, you get minus 131. Okay, so that's step 2. Now what? Well, let's just do a little sanity check here. These two columns are orthogonal because you get minus 4 over radical 5, minus 2 over radical 5 plus 2 over 5 radical 5. So these two columns are orthogonal. The first one has length 1. The next thing to do is to make this one have length 1. Well, the length of this column turns out to be radical 6 over radical 5. And so you need to divide by that. And that amounts to multiplying on the right by 1 square root of 5 over square root of 6, 1 down the diagonal. And that gives you 2 over radical 5, 0, minus 1 over radical 5. And the second column becomes a little complicated, minus 5 over 5 radical 6, radical 5 over radical 6, and minus 2 radical 5 over 5 radical 6. And the last column doesn't change, you get minus 1, 3, 1. And, well, that's step 3. Now, I don't really like leaving the second column in this form, so I'm going to rewrite that once as the first column doesn't change. The second column can be simplified to have a denominator of 1 over radical 30. And it comes out like this. Okay, so that's not a really new step. It's just simplifying the second column. And then the next thing that you need to do is you need to look at the inner product of these two columns and these two columns and multiply on the right by the corresponding numbers. And what you get is the following. When you take the inner product of the first two columns, what do you get? You get minus 2 over radical 5 minus 1 over radical 5 is minus 3 over radical 5. And what that says, you should put a plus 3 over radical 5 here. And similarly, you wind up with, when you calculate the other inner product, it turns out to be 14 over radical 30 So that says that you put in a minus 14 over radical 30 here, and that's the next step. Okay, so I copied the two matrices over. When you multiply them, the first two columns don't change, and the last column turns out to be 2/3, 2/3, 4/3. Okay, so that was step 4. And the final thing that you need to do is normalize this last column, and you compute the length of that column, and it turns out to be 1/9 times 4 plus 4 plus 16 is 8/3, that is to say radical 8 over radical 3. So you're going to multiply this matrix on the right by 1, 1, radical 3 over radical 8 in order to normalize it, and what you will get is 2 over radical 5, 0, minus 1 over radical 5, minus 1 over radical 30, 5 over radical 30, minus 2 over radical 30. And then the last column turns out to be, with just a little bit of algebra, 1 over radical 6, 1 over radical 6, 2 over radical 6. And so that is our Q. And let's just take a gander at this. The first column has length 4/5 plus 1/5 is 1. And the second column has length 25 plus 4 plus 1 is 30 over 30. And the last column has length 4 plus 1 plus 1 is 6 over 6. And if you take the dot product of any two columns, you get 0. So this matrix is indeed orthogonal. And the only question is, what's our matrix R? Well, you just have to go back through the steps. R is 1 over radical 5, 1, 1, times, the next thing I did was 1 minus 3/5, 1, 1. And then the next thing I did was 1 radical 5 over radical 6, 1. And then the next thing that I did was 1, 1, minus 3 over radical 5, plus 3 over radical 5, minus 14 over radical 31, and then last but not least, 1, 1, radical 3 over radical 8. And you just need to multiply all those matrices together. Okay, so let's multiply all of these matrices together. This is the matrix I called R on the previous slide, but I'd really like to call it R inverse. So let's do that. You'll see why in a minute. And when you multiply these, it's slightly painful, but what you get is 1 over radical 5, radical 5/6, radical 3/8. And what you wind up here is minus the square root of 3/10, minus the square root of 3/2, and minus 7 over 2 times the square root of 6. Okay, like I said, that's slightly painful, but it's just a matrix multiplication. So what have I computed? I started with the matrix A, and I multiplied it on the right by these matrices in order, which is to say this matrix, which I'm calling R inverse, and I got that that was equal to Q. So therefore, bringing the R to the other side, you get A is equal to QR. So that's why I called it R inverse, because it was on the other side. And you just compute that R is the inverse of this matrix here. And it turns out to be the following: radical 5, square root of 6/5, square root of 8/3 down the diagonal. And the other entries turn out to be 3 over radical 5, minus 3 over radical 5, and 7 times the square root of 2/15. Sorry, that's a little bit sloppy, but there it is. That's the matrix R, and the matrix Q is on the previous page.